Hello, welcome back. Today, we'll learn about how to solve systems of nonlinear equations. So if you've seen my previous video or another video about solving systems of linear equations, then much of this will be very similar, but there are some important differences we'll discuss. So our goals then are basically to be able to solve these nonlinear systems by the same methods we use for solving linear systems, the substitution method and the elimination method, and also be able to solve them by graphing. So first, let's briefly discuss what you mean by a nonlinear system of equations. So a system of nonlinear equations is some group of where you have n equations and variables. The main thing is you need to have the same number of equations as variables, and at least one of the variables is not to the first power. So in a system of linear equations, all your variables are to the first power. But in a system of nonlinear equations, at least one variable, doesn't have to be all, but at least one variable in one equation is not to the first power. So for example, here's an example of a system of nonlinear equations. So both in this case, both x squared and y, we have an x squared and y squared here in the first equation. That makes it nonlinear. Even if we just had simply one, either just x squared or y squared, not both, that would still be nonlinear. And so remember also with linear systems of equations, at least in two variables, your equations are the equations of lines. But here, for nonlinear equations, at least one of your equations is not the equation of a line, but something else. Could be a parabola, could be a circle, could be ellipse, could be a hyperbola, something like that. Now, what's one thing they have in common, though, with systems of linear equations is that basically the solutions to the equations are still points where the lines intersect. And in the same way, if they don't intersect at all, then there's no solution. And one thing that was different about systems of nonlinear equations, you can have many more possibilities, possible types of solutions. You can have no solution if they don't intersect. You can have one solution or multiple solutions. With systems of linear equations, you only had either one solution or no solutions, or they're both exactly the same graph. With nonlinear systems, you can have many more possibilities. They can also be no solution or the same graph. You can also have one solution, two solutions, maybe even three or four solutions or more. So that's the difference. Now, to solve those, then we'll solve them the same way. So let's take a look at our first example with the substitution method and review how the substitution method works. So here I'll just say solve number one. So solve using substitution. Number one, let's say we have this equation. X squared minus y is equal to 1. And 2x squared plus 3y is equal to 17. Make sure this is a 3. Okay. Now, this is a nonlinear system because we have in this case, in both cases, an x squared. That makes it nonlinear. Now, I like to label my equations A and B to kind of go through the process. So now this one can be solved potentially either with substitution or elimination or the addition method. But here we'll use substitution. So it says solve either equation for x or y, and that's your choice. So in this case, I think what I'll do, you can solve probably the first these as far as the easiest equation. So pick the equation that's easiest to solve for one variable. In this case, it's probably easiest to solve this equation for x squared. So I think that's what I'll do. So I'm going to solve equation A for x squared. Okay, and I don't have to solve for x, I simply solve for x squared. Now, if I add y to both sides, what I'll get is then x squared is equal to y plus 1. Okay, now, it's called the substitution method. I'm going to take this y plus 1, replace x squared, the y plus 1 in the other equation right here. Okay, so once again, so plug this into equation B and solve. So recall the problem is we have two equations with two variables. What we like to be able to solve is one equation for one variable. We know how to do that. And so this will allow us to do that. So basically by plugging this into the other equation, we're going to get one equation for one variable. Also remember, always plug it into the other equation, not back in the same equation. So if we do that, we have 2x squared. We said x squared is this, y plus 1 plus 3y is equal to 17. Okay. So now we have just one equation for one variable. Okay. And so first, let's get simplified to the left side. So let me distribute the 2. So we have 2y plus 2 plus 3y is equal to 17. And so that's going to give us 5y plus 2 is equal to 17. And then subtract 2 from both sides. We have that 5y is equal to 15. This particular case works out nicely. This then is going to be y is equal to 5. Okay, and actually, wait just a minute. Will- all right, I need to pause this just a minute and I need to fix my screen. So give me just a moment and I'll pause. Okay, welcome back. All right, so where we were is we got an equation, one variable, solve it now that y is equal to 5. Now, if we take that and we plug that, substitute back into actually either one of the equations, doesn't matter which one. I'm going to pick the first one, but actually plug it back into either one. Plug y equals 5 into equation A to find x. Okay, if we do that, then equation A was x squared minus y equals 1. So that's x squared minus y, and y is 5 is equal to 1. Okay, and so that's going to be um, add 5 to both sides, x squared is equal to 6. Okay, oops, I should realize that, sorry, I made a mistake. Y should be 3, not 5, my mistake. Well, something's not going to work out right. That's what it was. So that's actually going to be a 3, not a 5. Let me go back and fix that. There we go. So then x squared is going to be 4. And then, of course, take the square root of both sides. And so this is plus or minus 4. And so this is x squared equals plus or minus 2. Okay. Now, how many solutions do we have? We have 2 solutions. So our solutions, where this place meets. So we have x could be 2 and then y is 3. And then the other one is x is negative 2 and y is 3. Okay, those are our 2 solutions for this example. Let's actually take a look at that on Desmos. And we're also solving by graphing. So if you want to solve by graphing, then basically determine where both lines intersect. You can approximate it or possibly find the exact solution. Okay. Now, the nice thing about Desmos is you can actually plug in these equations just as they are, and it'll actually give you the graph and something that does graph. So x squared minus y is equal to 1. See, that's a parabola. Then graph the others. So in this case, we had one variable, the first power 1 squared, that gives us a parabola. And the other one is 2x squared plus 3y is equal to 17. And see, that's also a parabola. Then if we check, so the solutions are the points where they intersect. And we see this one is negative 2, 3, and 2, 3, just as we said should be. Those are the values we found. And those are the only places it intersects. Now, so that's how we solve that example. Okay, let's take a look at our next example. This time, let's practice with, so as you see, this works, the process is essentially identical to the substitution method with linear systems. Just simply we have nonlinear systems, so that we can have different kinds of solutions. All right, and this time, let's actually do an example with the addition or elimination method. So they solve with, or using the elimination method, or sometimes called the addition method. Let's take a look at this example. We call it number 2, doesn't matter. So we have 3x squared plus 4y equals 17. And 2x squared hang on just a minute. I'm trying to read I need to check something. So once again, let me pause this again. I need to make sure my example is correct. Okay, we'll come back. So I just have to double check my equation. So my other equation then is going to be 2x squared plus 5y is equal to 2. And once again, I like to call mine A and B. Now, but here we use the elimination or addition method. So remember how this works is for our course, we have two rules of equations. We can multiply both sides of an equation by the same non-zero number. And we can also add, subtract the same value to both sides of the equation. Those are our two rules for equations. So the way this works is you basically pick one variable to eliminate, and that's always up to us. And it's usually best to pick the easiest one. In this case, I'm not sure one is particularly easier than the other. Let's say we want to eliminate x. In this case, it probably is better to eliminate x, and that will give us since y. And once again, I should also say this is a nonlinear equation because x is squared in both cases. Let's eliminate x. Not necessarily it's easier to eliminate, but actually eliminating x will just leave us with a linear equation to solve, which would be simpler. Okay. Now, what we want to do then is that basically what we want is the coefficients or numbers from the x squared to be the same except opposite signs. So when we add these equations together, the x squared will go away. X squared terms will go away. We'll just be left without an x. That's the way we take care of. Since the problem is we have two equations with two variables, so that's the way to get one equation with one variable. So here, it's like much like finding least common denominator. Find the smallest thing that both these numbers are going to evenly, and that's 6. So I want to make one of these positive 6 and negative 6. It doesn't matter which one's positive or negative. So I'm going to multiply equation A by 2, and then I'm going to multiply equation B by negative 3. Once again, it doesn't matter which one is negative. If I do that then, so I have 2 times the first equation, 3x squared plus 4y is equal to 2 times 17. And then over here I have negative 3 for the second equation times 2x squared plus 5y is equal to negative 3 times 2. We do that, and we get to the top of equation A again, 6x squared plus 8y is equal to 34. And the second equation, I get negative 6x squared minus 15y is equal to negative 6. Okay, double check, make sure everything is correct. Now we add the equations. That's our next step. And so by adding them, it should eliminate one of our variables. Okay, we combine our x's, negative 6x squared and negative 6x squared is 0x squared. Then combine our y's, 8 and negative 15 is going to be negative 7y. And then only 34 minus 6 is 28. Okay, so now we have one equation with one variable, which is easy to solve. So negative 7y is equal to 28. And also in this case, it's easier to solve than it would have been if we'd eliminated the y. Divide both sides by negative 7, and y is negative 4. Okay, now we have one of our solutions. And then once again, like we did in the substitution method, plug this back into either original equation, that doesn't matter, to find x. So I'll just plug into, let's see, I'll plug in the first one. Plug y equals negative 4 into equation A to find x. And if we do that, then we have 3x squared plus 4y, and y is negative 4, is equal to 17. And of course, we have 3x squared minus 16 is equal to 17. All right, add 16 to both sides. So we have 3x squared is equal to, it's going to be 33, I guess. And then, of course, divide both sides by that. X squared is equal to um, 11. So that's right. I believe it is. Okay. Then take the square root of both sides, and x is equal to plus or minus the square root of 11. And of course, the square root of 11 doesn't simplify. And so our solutions then, we're going to have two solutions. And so one solution is the square root of 11 and negative 4. And the other solution is the negative square root of 11 and negative 4. Okay. And also the square root of 11 is approximately, if we do that, let me use my calculator. It's approximately 2 decimal places, 3.32. Okay, so let's go to Desmos and try that. Let's make sure it works. So I'm actually turn these off in case we want them for later. And so once again, these are both going to be parabolas because they have one variable to the first power and one variable to the squared. So 3x squared plus 4y is equal to 17. And our second equation is 2x squared plus 5y is equal to 2. And here are our two solutions. And one here and there, if we double check, we said that should be approximately negative plus or minus 3.32. Yeah, as we can see, plus or minus 3.32 and negative 4. Exactly. So those are our two solutions. Okay, so that's the elimination method. And once again, it works essentially just like the elimination or addition method does when solving systems of two equations. All right, let's look at one more example. Let's actually solve one strictly by graphing. Okay, so let's look at this example. So number 3, we have x squared plus y squared is equal to 9. And we have x squared minus y squared is equal to 1. Okay. Now these we potentially could solve either addition or elimination. Let's actually do graphing. Now this one's both interesting because the type of equations or types of graphs these are. So if we recognize this as the equation of a circle, and this, if you're not familiar, this actually gives what's called a hyperbola. So let's graph both of these and see what happens. So we graph x squared plus y squared equals 9. That's the equation with a radius of 3. It's a circle with a radius of 3, center at the origin. And then x squared minus y squared equals 1 is a hyperbola. And if we look, we have 4 solutions. Okay. And so we have 4 solutions, as you can see, and this then approximates what they are. So you can get this do the same thing using either a graphing calculator potentially or Desmos like this. But if you just graph both, and you can see that there are actually 4 different solutions, and you can approximate each different solution. Okay, and so we can also take that example we wanted, then solve it using addition method or elimination method. All right. Let me do one more thing. Let me actually show you what happens when there's something with no solution. Okay. So let's look at a system with no solution and just show what that can look like. So let me actually make up one. So let's do one system is just y equals x squared, just a parabola. And also let's have y equals negative 2. Now, why I chose this system, this is a very basic system, is because we graph both of these, we'll see that there is no solution. Of course, y equals x squared as a parabola with the vertex at the origin. Y equals -2 is a horizontal line. It's at -2. And so you see there's no intersection, so there should be no solution. How do we see that? Well, in this case, let's just use the substitution method. And this is also a simple example because what we can do is we can actually, since they're both equal to y, just set them both equal to each other. So here, I'm picking a very simple example just to show what happens when there's no solution. In this case, since they're both equal to y, we can set them both equal to each other. And so we have x squared is equal to -2. Then, of course, you can take the square root of both sides. This is plus or minus the square root of -2. And of course, convert it to I form is x squared equals plus or minus I times the square root of 2. But notice this is a non-real solution. This is an imaginary solution. And so what that means is no real solution. Okay. And so the graphs, as we saw, don't intersect or don't cross each other. It's just like we saw with systems of linear equations. To have a solution, the graphs have to intersect. So if there's no intersection, there's no solution. These graphs don't intersect. Let me write that word a bit better. Okay, so that can also happen, as we saw then. That's exactly the case. If we graph it separately, we see they don't cross each other. There's no intersection. So let's summarize. What we've learned is basically how to solve systems in 2 dimensions and 2 variables, solve systems of linear or nonlinear equations. And we saw that basically solve them by graphing, seeing whether they intersect or not intersect. You can solve them. Actually, I realize I didn't. Just a second. I realized I didn't say anything else about the ones we said we're going to solve by graphing. So I was here, so you just used Desmos. We have 4 solutions. They didn't list those. They didn't list those solutions, but we saw from Desmos there are 4. Okay, so then we learned to solve by graphing, finding where they intersect, and also learned to use or apply the substitution method and elimination method to solve systems of nonlinear equations. Thank you. Have a good day.